distribution of the sample mean. So here, as the title indicates, sampling and sampling distribution concentrates on two ideas. The first one is sampling, and the second one is sampling distribution of the sample mean. And as you may know, sample mean is a statistic of the parameter population parameter. So here I will try to cover what are the sampling techniques and what is the sampling distribution of the sample statistic, that is the sample mean, right? So sampling is a device or a technique is to draw inference about the whole population by simply investigating or observing or measuring a few of sampling units taken from the population. And another basic concept we have to define before going to the sampling technique is sampling unit. So as the name indicates, sampling unit is one of the possible member of the population that would be included in the sample, or that's an element of population that will be a person or object on which observation can be made or from which information will be collected. Another important concept is sampling frame. So just a name, again the name indicates frame is just some shaped thing. So sampling frame in the statistics is list of sampling units in the population. That's prearranged list of samplings in the population. Another thing we have to cover is sampling error. So sampling error is an error that's introduced because of or due to error in selection of sample, or that's in terms of measurement, that's the distance between population parameter and an estimate which is derived from the random sample. And another one is everyone should be familiar with census. So surveys can be census survey and sample survey, but the census survey is a full investigation, and that should cover every individual unit in the population. And on the other hand, sample survey is just taking some portion of the population from some portion of the population as a sample. So what are the reasons behind taking sample? Why not we investigate the entire population? Yes, what are the reasons of taking samples? So the first reason is sampling saves money. Sampling saves human power. Samples saves your money. So the cost of obtaining information through a sample would be a lot less than obtaining it through investigating the entire population, as census. Or maybe sampling may be your only option, yes, for the study in some specialized areas. So then if the survey requires highly trained personnel and specialized equipment, so sampling will be the only way or the only option. Observations or experimentation could be destructive in nature in quality control, like testing the average duration of bulbs and testing the quality of wine, beer, and etc. In such area, sampling only the only feasible option for the study. What may be the other reason? The other reason may be your population may be too large or very huge to cover sampling. So sampling will be the only way for the study. And in sometimes results obtained from the sample are more accurate compared to that of a census result. Why? People obtain or data obtained from the entire population may be very, very huge and may be difficult to manage, and just collecting information from the sample, if they are a good representative of the population, may be very, very good or maybe accurate compared with the census. So just you will have some universe, and from the universe that there will be a population that the investigator is interested, and so sampling is just you pick some portion of that population in this figure, the green area, and usually the sample is less than the population in the population found in the universe. So you see, I'm showing you in this figure there are a lot of population, but the lucky ones or the unlucky ones are the 3 people that is considered as a sample. Yes. So sampling is a procedure in which some member of the population are selected as a representative of the entire population. So the investigator will assume that these 3 people are a good representative of this many population. Yes, implies that I will do inference about that total population based on these three individuals, and they are expected to be a good representative of this entire population. So what are the types of sampling? Sampling may be divided into 2. The first one is probability sampling and non-probability sampling. Or probability sampling is called or can be called as random sampling, and the non-probability sampling is non-random sampling. So there are a lot of probability sampling techniques and non-probability sampling techniques. From these probability sampling techniques, the simple random sampling, systematic random sampling, stratified random sampling, cluster sampling, and multi-stage sampling are amongst the common probability sampling techniques. So let us see each one by one. So the first type of random sampling or probability sampling is the simple random sampling. In simple random sampling, every unit in the population has equal probability of included in the sample. Yes. So how can you take a sample using this simple random sampling? Yes, the first thing is we have to construct the sampling frame. We have to have a clear frame to take sampling. How can you create the frame? We have to list all the subjects and number them. So if I have 10 individuals, I have to give 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or A, B, C, D, E, F, G. Yes. And another thing is I have to decide the sample size. So if I have this 10 people, I may be interested to take the 3 ones, and just anyways we have to decide the sample size. So how to take some individuals or just determine as a sample size? There is 2 options. One, I can use table of random number, or I may use lottery method, or this lottery method can be substituted by computer generation. So these 2 methods, just for example, lottery method implies that I have a list of numbers, and just I can collect in a container, and from that I will pick numbers as much as I can get my determined sample sizes. Then I will stop there. So if the first lottery is number 1, I will take information from the people who have assigned as number 1 is from the frame. Good. So another one is let me come to the advantage and disadvantage of this type of sampling. The advantage is the selection cannot be biased. Why? Everyone in the population have the chance to be included or to be part of the sample, and this is a major advantage of this type of random sampling. The disadvantage is you have to have a complete list of individual sampling units, and this is a difficulty. Just in some situations it may be difficult to have a list of individual sampling units, right? The second type of probability sampling technique is the systematic random sampling. This is similar to simple random sampling in design. Why? Because it requires a list of all population as a sampling frame. So similarly, as simple random sampling, we need to define the size of the sample. Yes, we need to define the size of the sample, and we have to compute the sampling ratio 1 in capital N. That capital N is what? That the total population, and we have to use as the sampling interval k. K is will be our sampling interval. So I have to have a random start. I have to have a random start. Then I will select every case element that's based on the desire. So sample size and sampling interval, the size should be interval, right? Sampling interval is k. That's calculated as the ratio between capital N and small n. The small n is my determined sample size, and the capital N is my population size. Yes, then I will take every case element. If my start is 1, for example, the 1 plus k, the first plus k will be my second sample. The 1 plus k, that is 1 plus 2k, will be my third sample. Yes, then 1 plus 4k will be my fourth, and like that. What is the advantage of this random sampling? It's equivalent to the random sample, but easier and faster to implement. Why? Once you have the case interval in the frame, and picking every sample will be very easy, and that's easier and faster to implement. Disadvantage: it can be biased if the list has a pattern. So for example, if you take the first one and you will take the case, the 1 plus case, the 1 plus 2 case, the 1 plus 3 case, and unfortunately, if this have a pattern, and this may lead you to some bias, right? So let us see by example. Now let us assume that I have my survey is a hospital satisfactory survey. Yes, and my sample size is n is equal to 50. Yes, and I have a total population of 200. That's capital N, right? Yes, and I have to assign numbers for every 200 individual. 1, 2, 3, 4, 5, 6, 7, 200. Right? I will assign a number. So now the next task is I have to know my sampling interval, that is k. K is the ratio of population size to the sample size, and my population is 200. Then divided by 5 will be 4, and that's my interval. And then randomly select the first element. For example, that's the first element. I select the first element, and I will select every case element again. So for the interval, if I select the first one, I will select the 1 plus case element. Yes, then the fifth will be my second, and the third will be 5 plus 4, that's 9, and 9 plus 4, 13, 13 plus 4, 17 will be my selection, as much as I to have sample 50, right? Another type of random sampling is stratified random sampling. In this sampling technique, the entire population of interest should be divided into non-overlapping stratas. Non-overlapping implies an individual who found in stratum 1 should not found in another stratum, whatever that means in that non-overlapping concept. So for strata, for example, I may use age categories, I may use gender like male, female. Residence, urban, rural can be used as a strata. Yes, so first I have to identify the subgroups or strata, then construct a sampling frame in each stratum. So strata is the plural and stratum is the singular here. Then the sampling will be performed in every stratum independently. Yes, I have to have a sampling frame in every strata independently. and I have to take sample from each strata. What's the advantage of this sampling technique? This sampling technique is helpful to reduce sampling variability, and it gives a sample proportional to the magnitudes of differences. Yes, it's just for small number of females and for high number of males I have to take proportional sample in some times, and I may not have to allocate equal sample size for the two genders, for example, and then I will get and then again I will reduce the variability, the sampling variability. So this is one advantage. So what is the concept behind using this, the logic behind using this strata? I will assume elements within the strata are homogeneous and there is heterogeneity across each strata. So now I will take a sample from every stratum independently. So in each stratum, simple random sampling or systematic sampling can be useful. Yes, to take samples from individual stratums. So here samples may be taken, equal samples may be taken from every stratum, or proportional allocation may be used from each strata. So if it is proportional allocation, I have to take large sample from stratum that has large population, right? I have to take small sample from population from small population. If it is equal allocation, I have to allocate equally for every stratum, right? If I have 50 samples, I have decided to take 50 samples. Then if I have 5 stratums, then, or 5 strata, I will take 10 samples from the 5, and 5 times 10 will be 50, right? Then that's equal allocation. And just this is some illustrative example. And in the next class, I'll try to cover a number of sampling techniques